So as we move on to question 9, we see we've got some new notation. Capital R, subscript O, comma 180 degrees, then line segment AB. What does this mean? Okay, it's telling us to do something. What does it mean? So we have capital R, subscript of O, comma 180 degrees, then line segment AB. Capital R in this context means rotation. Okay, so we're going to be rotating. How are we going to be doing the rotation? Okay, the center point is what comes first. So O is the center point. Okay, O is the center point. What comes next is the degree of rotation. Okay, so this is the degree of rotation. So around the center point O, we're going to be rotating 180 degrees. And finally, the last thing, line segment AB, is what is being rotated. Okay, so we're saying here that we are going to take line segment AB, that's what's being rotated, and using O as the center point, we're going to rotate line segment AB 180 degrees around O. Okay, so let's go ahead, make sure that that makes sense to you, and let's go ahead and do this. And notice one other thing that the problem specifically says, it's in parentheses, but it's important. Order matters. Order matters. So that means that when we give the new line segment that AB is being mapped into, okay, AB here is the pre-image going to the image, we've got to give the line segment in notation so that A prime, whatever A prime is, comes first, and whatever B prime is, comes second. Okay, so let's go ahead and let's see what AB is being rotated into, where it's being mapped into. Let's go back to our problem sheet and take our patty paper and go ahead and place the two figures right on top of each other. Okay, and now let's remember, so we are rotating this around point O. Okay, so the pencil is going to be here at point O. Now we're specifically going to rotate line segment AB. So let's write in A and B. So we know exactly which is point A and which is point B. Okay, we had R from an earlier problem, but we're really paying attention now to A and B on the ends here. Okay, and we're rotating around O, and we're going to rotate 180 degrees positive, which means counterclockwise. So let's go ahead and do it. This is 90 degrees. This is now 180 degrees, and we're mapping the triangle right into itself. And let's see where AB ended up. Okay, AB ended up on the bottom. Okay, so we've got A and B here on the bottom, and we've got to see what A mapped into and what B mapped into. So let's take a look. A maps into C. B maps into D. Okay, let me flip that again so you can see B maps into D. Okay, so AB in order becomes CD. So that would be the answer. We have to write that in here. Line segment AB now is line segment CD. Okay, that's the answer to number 9. Number 10, let's take a look at this notation. This is saying that we are rotating triangle AOV. And where is triangle AOV? AOV. Okay, we are rotating triangle AOV about the center point O again, but this time 180 degrees in the negative direction. Okay, so we've got to map triangle AOV and rotate it around O. So let's go ahead. I'm going to keep it the way we had it before. We've already labeled A, and in this case, let me write this in red ink so we can kind of see AOV. A, O, V. Okay, Okay, so there's AOV, and we are rotating around O still, right? According to the notation, we're rotating around O and 180 degrees in the negative direction, which is clockwise. So let's start here, and remember, order still matters. So we've got everything all set up. Let's now rotate in the clockwise direction, 180 degrees, and let's see where AOV ends up. Okay, we've got our triangles right on top of each other. Let's look for AOV. Okay, A is down here. What did A become? C. Okay, O. Did O change? No. O is still O. Remember, the center point is always fixed. So this became C. This is still O. And what did V become? V became S. Okay, so triangle AOV became triangle COS in order. So let's put that answer down. Triangle COS. COS. Okay, and again, if we look at it, we can kind of see what happened. Try to visualize it in your mind, what you just did with patty paper. Okay. Now we have two other questions here, and these are about reflections. So these are sort of memory questions. In other words, the purpose for these questions is just to make sure you didn't forget about reflections. Okay, so let's go and do these two memory problems. If the rectangle is reflected over line segment AC, then the rectangle reflects onto itself. Well, that should be an easy one by now. So let's put this back up here. Let's make sure we label A and C. I'll put them both in red ink so we can definitely remember which line is line AC. Okay, so we're going to be reflecting over this line. And the question is, if we reflect this rectangle over this line, will it reflect onto itself? So let's go ahead and reflect AC onto AC. Make sure our A is on top of our A, which it is. And our C is on top of the C, which it is. And is the rectangle mapping into itself? Obviously not. Okay, so this is obviously false. And then if the rectangle is reflected over RT, then the rectangle reflects onto itself. So let's again set this up, and let's remember where RT is. And I'll write that in blue ink here. Okay, RT. R is up here. T is down there. And I think you're going to see if we reflect over RT, if we line up RT with RT like such, then we do map the rectangle into itself. Okay, so R is there, mapping into R still. T is down there, mapping into T still. So true, the rectangle does map into itself. This would be true.